Now in this video we'll see the configuration of Auto RP with multiple RPs. Now the main advantage we get with the multiple RPs is it's going to provide us the redundancy, and also if we want we can also do something called load sharing. So we are going to practically verify how to configure multiple RPs by using the Cisco proprietary method. Now if you just get back to some of the basic things what we have learned. Now if you want to advertise the RP information, probably we need to configure two things like candidate RPs. Now candidate RPs are the possible routers which are advertising themselves as an RP, and then we have something called mapping agent. Mapping agent is something providing the information to the rest of the domain about the RP informations. Now all the routers must know who is the RP, and our mapping agent is the one who is providing the information. Now there might be some scenarios where you may have an RP configured. Like in this scenario, let's say I got an RP here, this router, and this RP goes down. Now if there is no RP, if the RP goes down, in that case probably the clients, let's say I have a source sending a multicast traffic, will not be able to send PIM register messages, and also the receivers, I have a receiver here, will not be able to send PIM join messages. So RP is something mandatory if you're using PIM sparse mode. And if I go with a single RP, then there might be some scenarios where if that RP goes down, it's going to be a single point of failure, and that is something we really don't want. So we always want to have redundancy for the RP. Now in those kind of scenarios we can configure multiple RPs. Like in this scenario, I can configure the router 1 and router 3 as an RPs. Now if you configure multiple RPs, probably they will advertise themselves as an RP, and then the mapping agent is going to learn the information about the RP from multiple routers. It's going to select anyone as an RP based on the highest IP address. Let's say in my scenario the IP address of the router 3 is higher, so it's going to decide that router 3 will be an RP, and it's going to propagate to the rest of the domain that router 3 is an RP. Now in case if this RP goes down due to some reason, the mapping agent is going to provide or propagate the information about router 3 is an RP. Now at a time we are just using only one RP. If you configure multiple RPs, only one RP is going to work. So we cannot use the same RP, two different routers as an RP for the same group. But we can do some load sharing in some scenarios. Now when it comes to load sharing, what I can do is, let's say I got two different groups, and these are the two different groups we are using the multicast traffic, and we can configure for load sharing. I can configure the router 2 is an RP for this particular group. I can write in an ACL, and I can write another ACL which is going to match this group address 224.3.3.3, and we are going to make the router 3 as an RP. Now if you configure separate RPs for separate groups, it's going to provide us the load sharing option, where the RP is going to provide the information that if anyone want to receive the multicast traffic for 224.2.2.2, it's going to register with the router 2, and the receivers or the sources who are sending the multicast traffic or receiving the multicast traffic on 224.3.3.3, they will register themselves with RP. Now in this way we can reduce the extra overhead on a single router, because if you make any one router as an RP, probably it's going to add some more extra overhead. Now we can do something called load sharing. Now probably in this video we'll get into some more in detail with some configurations in the command line. So let's go ahead and verify the same in our command line. Now for verification, I'm going to use the same routers which we used in all our multicast labs. Now the first thing, there is an IGP which is pre-configured here, and I'm using OSP of area 0, and all the routers are forming the neighborship, and the routes are coming. And then I'm going to enable IP PIM sparse mode here. So I'm going to start the configuration from the second step, and here I did the OSP of configuration already, because I don't want to do that again here. And if you go and verify on the router 4, if I go show IP OSP of neighbor, now I can see on the router 4 there are 3 neighbors, and if you verify the routing table, I'm able to see the route from all the routers, from the router 5, router 1, router 3 and router 2. And similar way, I'm going to check on the router 2 as well. Show IP OSP of the neighbor. I got 2 neighbors. And I'm going to enable IPPIM sparse mode on all the routers. So the first thing I'm going to say IP multicast routing. And then I'm going to enable on all the connected interfaces. Interface S1 by 0 as well as interface S1 by 1. So I got the same interfaces on all the routers. So I'll be using copy paste on all the routers. So almost on all the routers I got the same interfaces, and on the router 3 as well. And then on the router 4 also I'm using the same interfaces. And on the router 4 I got one more extra interface, that is S1 by 2. And on the router 5 I just got only 2 interfaces. One is S1 by 0 and S1 by 1. So I'm not enabling on S1 by 1 here. So even if you enable, it doesn't make difference because anyway I'm not using S1 by 1 here. Now once we configure the sparse mode, now in this scenario what we'll do is we'll try to make multiple RPs. So the first step we'll see with multiple RPs here. So I got my OSP of configuration, verification. If you want to verify the neighbors, that's a good practice always. Once you are done with PIM, verify the neighbors. On the router 4 I should see 3 neighbors. And on the router 2, I should see how many neighbors? 2 neighbors according to my topology. Show IP PIM neighbors. Now the next thing is I want to configure the multiple RPs here. Now we are going to configure 2 different routers as an RP. So the router 1 will be an router 2 and router 3 will be an RP, and the router 4 will be a mapping agent. And we are going to use loopback 0 interfaces for the RP. And we need to ensure that all the devices should be able to listen to that Auto RP announcements. And to make that possible, we need to configure Auto RP listener. So we have seen this in the previous classes, like by default, the Auto RP uses 224.0.1.39 and 40 multicast addresses. Each and every router has to listen on this multicast addresses in order to learn about the RP information. Now, if you configure this command IPPIM Auto RP listener, it will allow the routers to listen to the advertisements. So let's go to the configuration here. And my requirement here is I'm going to configure the router 2 is an RP, as well as router 3 also will be an RP. So I'm going to configure 2 different RPs so that anyone can become a primary, anyone will be the RP here. And by default, it's going to select the RP based on the highest IP address, and we are going to configure the router 4 as a mapping agent. So let's configure this. So first I'll start with the mapping agent configuration. So on the router 4, we are going to say router 4 will be an RP. So first thing, I'm going to use the loopback interface. So I'm advertising the loopback interface in my OSP of domain. Now the router 4 is having one loopback to 14.0 network. It's pre-configured in my topologies. So if you want to verify, we can verify with show IP interface brief. I got the loopback 0 interface. It's not present in the diagram, but it's pre-configured in my router here. And the next thing I'm going to advertise, I'm the RP. So I'm going to send the discovery messages and the loopback 0 and the scope. Let's say I'm using 10, the TTL value. So PIM is ignored here because on that particular loopback, you must enable the sparse mode. That's mandatory. And once I enable this, it's not going to send any warning message. So I'm going to configure the router 4 as a mapping agent, which is going to send the discovery messages, and that particular interface is advertised in IGP as well. Now the next thing, we are going to configure the router 2 and router 3 will be an RPs. So the first thing, I'll start with router 3 and I'll say that IP PIM. And before I do this, again, I need to ensure that I'm advertising the loopback interface. On the router 3, I got a loopback interface here. And then that particular loopback interface also should be enabled with sparse mode. And then I'm going to say send RP announcement, send RP announce, loopback 0, and the scope is 10. So I'm going to use the same commands on the router 2. Router 2 also, I'm going to configure the RP. Let me advertise the interfaces. So it's a /24 and then interface loopback 0, sparse mode, and then I need to say IP PIM send RP announce. I'm going to make loopback 0 as an RP. Now once we configure the router 2 and router 3 as an RP, now in this scenario I configure the router 2, router 3 as an RP for, I didn't mention any specific group, which means these are the RPs for all the multicast groups. Now to verify this, we can go to router 4, which is my mapping agent. Let me write down here so that when we are moving, so there's an RP here which is 12.001, the loopback, and the router 3 13.001, that is also an RP, and the router 4 is a mapping agent. So that's 14.001. Now in my scenario, if I give show IP PIM RP hyphen mapping, show IP PIM RP and then mapping, so there is a space between them. So if you go with the show IP PIM RP mapping on the router 4, now you can see this router 4 says it's a mapping agent and it's going to learn from 224.000 and the RP is 13.001. Now if I try to go to router 1, on the router 1, if I give show IP PIM RP mappings, now the router 1 also learns about the RP, that is router 3, and now here actually there are two different RP advertisements coming from two different routers, and this advertisement will be mapping agent will see that there are two RPs and it's going to decide based on the highest IP address. Now in my scenario 13.001 is the highest IP address, so the router 3 is going to be decided as an RP. Now here the router 2 cannot become an RP here unless the router 3 is down. Now for further verification, I can simply go to interface loopback 0. I'm going to shut down this router 3 interface, assuming that my router 3 goes down. Now I'll go to router 4. I'll give some command called clear IP PIM RP mappings. So just to refresh the mapping information, and if I give show IP PIM RP mappings, and now I should see that router 4 should learn the RP has to be router 2. Now if you want to enable these messages, you can always go with debug IP PIM Auto RP commands to listen to these messages. You can always use that. So I'm going to clear the mapping. Let's see some of the debug commands as well. I can see the RP Auto RP build discovery packet. I'm expecting some messages. It takes some time. So let me use this clear IP PIM mappings on all the routers. So maybe I'll also do the same thing on all the routers. So just to clear it so that it can come faster. So I'm going to clear IP PIM RP mappings on all the routers. Let's do it on the router 1 as well. On the router 3. Because when you're verifying some information, either you have to wait for the mappings to come up, or you can simply use clear IP PIM RP mappings. Now here if you try to see here, I'm not learning the RP information because actually I forgot one command here to configure, that is PIM Auto RP listener. No, I just forgot this command to configure this. I thought I configured that, because if you just get back to the previous videos, we have seen that by default, you know, to learn about the RP information, they must register to this addresses, and that can be done either by running a sparse mode or by using an Auto RP listener. Now in my scenario, I'm going to use Auto RP listener here. Let me just quickly configure this on all the routers, IP PIM Auto RP listener, and I'll do this on all the routers. So I'm going to configure on the router 1, and then on the router 2, on the router 3, and then on the router 4, and finally on the router 5. Now I did the shutdown command. Now if you just observe here, once I enable the debug command, debug IP PIM Auto RP command, then I cleared the RP mappings. Now I can see I'm receiving a RP announce from 12.001 this time, and the reason is it is building the mapping entry for this, that for all the multicast group addresses the RP is 12.001. Okay, so and then it is sending a discovery messages to all the router, all the interfaces, saying, advertising the RP information. Now if you just get back to the router 1, now the router 1 should see this router 2 is selected as an RP, and the reason is the router 3 interfaces we did shut down. So let me make this interface back to up, the loopback interface. And once this interface comes back to up, now the router 4 should listen some RP messages from the router 3 as well once the interface comes back to up, because the router 3 also will advertise the information. So you can see it's receiving some RP announce from 12.001. It should get from router 3 as well. So I just did the clear IPPIM RP mapping command just to remove all the RP information on the mapping agent, and then I'm expecting some RP announcement messages. Now I can see here I'm receiving RP announce from the router 3. I can see the router 3 is advertising itself as an RP here, and if I go and verify show IPPIM RP mappings, I can see the RP information is 13.001. And if I go and check on the remaining routers, on the router 1, the router 1 will see the router 3 as an RP. Now in case if you configure multiple RPs, probably the candidate RP will be decided based on the highest IP address. Now this way, if any one of the RP fails, still the mapping agent is going to decide the another router as an RP, and it's going to propagate that information to the rest of the domain. Now in this way, we are getting a redundancy option where if RP fails, we got a backup RP. But we cannot use both the RPs at the same time for the same multicast group addresses. Now if you want to do some load sharing, we will get into that in a continuation of this video. Probably in the next video, we'll continue with the load sharing as well.